fxx and fyy. We are differentiating again with respect to x. We're differentiating again with respect to y. Is that okay so far?
Yep.
What about fxy? Fx, but now we differentiate with respect to y. How much will it be? That's it. And now if I want to check how much is fyx, fy, and now we differentiate with respect to x.
-3.
-3 again, of course. Good. So now this was part 1. Part 2. Now we have to solve the system. Fx equals 0, Fy equals 0. To see what we get from there. But Fx is 3x squared minus 3y equals 0. And Fy is 3y squared minus 3x equals 0. So this is the system. Good. Of course, I'll divide both sides by 3. And I get x squared equals y, and I also move y to the other side. And here I have that y squared minus x equals 0. So I have to use substitution, and I will replace y in here by x squared, but I have to square. So I have x squared squared minus x equals 0. Any questions so far?
Yeah, are they always going to be inverses of each other? Like the different answers, I guess?
Not necessarily. When you say inverses of each other, what do you have in mind? Because inverses of each other means 1/2 and the other one is 2.
No, if you look at f of x and fy, so you got fx equals 3x squared minus 3y.
No, it just happened. No.
Oh, okay.
No. So let's go back. Very good question. Excellent. Here it happened again, but let's see on this one. So this was fx. And where is my fy? See? Oh, where's my fy? Okay, see? There is nothing, no connection whatsoever. So x squared plus 6y plus 8x cubed y, 2xy plus 12x squared y squared. So this is fy, and this is fx.
Okay.
No connection. Good question, thank you. Where am I now? Okay. Okay, so we simplified, I'm just checking here. I copied 3x squared minus 3y, 3y squared minus 3x. Yeah, okay, perfect. So we divided both sides by 3, and then I moved y to solve for y. And now I have y squared minus x, yes, and I put it in. So I have x to the 4th minus x equals 0. So, of course, I will factor out x. Then I have x cubed minus 1. And let me refresh our memory on a cubed minus b cubed, the factoring of a difference of cubes, which is a minus b times x squared, a squared plus ab plus b squared. So I'll continue factoring x minus 1, and then x squared plus x plus 1 equals 0. I expect degree, because it's degree 4, I have 4 solutions. One solution is x equals 0, the other solution is x equals 1. This will not have real solutions. There will be 2 imaginary. So these are the 4 solutions: 2 imaginary, 0, and 1. Okay, so now we have to determine the two points. We have x is 0 and x is 1, but I have to determine the y values. So, where am I? Right here. So when x is 0, y is 0. When x is 1, y is 1. So let's say we have point A and we have point B. That was part 2. Now we have to evaluate in part 3. We have to evaluate D for 0, 0. And then we have to evaluate D for 1, 1. So let's evaluate. Let's write what D equals to. So D equals fxx evaluated at 0, 0 and then at 1, 1 times fyy evaluated at 0, 0 and then minus fxy evaluated at 0, 0 and squared. After I complete this, I will determine the other D. So this is for 0, 0. I will determine for 1, 1 as fxx of 1, 1 times fyy of 1, 1 minus fxy of 1, 1 squared. Okay. So now I have to dig deep. Where are my fxx and fyy are, so fxx is 6x. So then this piece with 0, 0 will be 0. Fyy with 0, 0 will still be 0, minus. Fxy will be negative 3, so times 9. So 0, 0 minus 9 will be negative 9. And when D is a negative number, this is a saddle point. D is less than 0. So this is not a max min. Good. So now we evaluate when x is 1, y is 1. So fx...
Slide your paper over. The other way. Yeah, thank you.
So now fxx with 1, 1, this will be 6 times. Fyy with 1, 1, this will be 6 minus. Fxx is the same, is always negative 3, and negative 3 squared will be 9. 6 times 6, 36, minus 9. All we care about is that this is a positive number. So when D is a positive number, there are 2 possibilities, either for a max or for a min. But in which situation? I have to determine fxx. So the max will be when fxx is negative, and when fxx is positive, is a minimum. So, but I have fxx is positive. So it's not the situation. So D is positive and fxx is positive. 1, 1 is a relative min. And that was it. I know we have to practice different things, but this is the end of the course. No more new material moving forward. Now they are also asking us to find the relative minimum. So this one is a relative minimum, but I don't know what it is. So I have to go back to the function, plug in 1, 1, 1, 1, and determine it. So f of 1, 1, maybe I should not, maybe it's confusing. I will erase this. I'll say gives, produces. 1, 1 gives or produces a relative min. This is the relative min when I plug it in the function. And 1 plus 1, 1 plus 1 minus 3. So this is negative 1. So this is the actual minimum, relative minimum. Where it is obtained? When x is 1, y is 1. How much is it? -1. No more new material beyond this, so please choose now anything you want. And this is all about the D test. We found the saddle point because D is less than 0. D less than 0 means no max min. If D is 0, the test is not applicable. And the function will have a max or relative min only if D is positive. It will have a maximum when f(x) is negative, and it will have a minimum when f(x) is positive. I'm ready for any question you want to pick. To determine the max min of functions with two variables, in two variables. Anyone would like to choose, or I will? Okay, I would like to choose then a word problem. So let's look at 17. And this is on page 547. So maybe I should share my screen so we can read it. Where are you, 17? Oh, I went too far. Okay, here it is, yes. Maximizing profit. Okay, the lead company, okay, finds that its profit P in millions, so I'm copying it. P of A comma P. That's confusing. They should not do that. They should not use P and P, uppercase P, lowercase p. I'm gonna change this into F, not to be confused with. Okay, so this is 2AP plus 80p minus 15p squared minus 1 over 10 a squared p and minus 80. Fine. A is the amount spent on advertising in millions of dollars. I have to take notes. A, millions, amount. Fine. And lowercase p is the price per unit. Okay, in dollars. Find the maximum value of p, which is function f, and the values of a and p at which it occurs. Fine. Step 1. What do I have to do?
Find f of a and f of b?
Yes, fa and fp. Very good, awesome. So we have differentiating with respect to a, p is a constant. So p is a constant, I'm differentiating with respect to a, so this is 2p. This is gone, it doesn't have a. I'm differentiating with respect to a, this is 0. I'm differentiating with respect to a, this is 0. I'm differentiating with respect to a, this is 0. But when I'm differentiating here with respect to a, I bring 2 down, negative 2 over 10, which is negative 1/5 AP. Now we differentiate with respect to p. So this is 2a, and this is plus 80, and this is minus 30p, and this is minus 1 over 10a squared. Before we find FAA and FPP and FAP and PA, we don't need the second one. Let's create the system. So 2p minus 1/5 AP must be 0, and 2a plus 80 minus 30p minus 1 over 10 a squared equals 0. So far so good? Any questions? Okay, so let's see what we do with this. It's quite ugly, but I chose it, so okay. cannot be 0. So if p cannot be 0, I can divide both sides by p. So when I divide both sides by p, I get the 2 minus 1/5 a equals 0. Oh, it's quite nice now, I see. So 2 equals 1/5 a, multiply both sides by 5, a is 10. Quite nice. So then I will plug in here, of course in here, to get p. Not a big deal. It looked kind of ugly, but then when I realized that we can divide by p, it was just a piece of cake. Okay, so let's plug it in and determine p. Good. Let's see what I'm with Tom here.